Welcome to the podcast covering a few examples of cost behavior. Let's take a look at an example. Based on costs at activity levels of 5,000 units and 6,000 units, we want to determine whether cost A, B, or C is either fixed, variable, or mixed. So let's look at cost A. Cost A at 50 or 5,000 units, total cost is $30,000 or $6 per unit. However, at 6,000 units, the cost per unit is still $6 per unit and total cost is $36,000. This indicates that since these are still the same, that this is a variable cost. Now looking at cost B. Cost B at 5,000, we have $6 per unit and $30,000 in cost. However, at 6,000 units, we still have total cost of $30,000, yet our cost per unit is now $5. Thus, B is a fixed cost. This is because our total costs were the same no matter what the activity level was. Then we have cost C. Cost C at 5,000 units is again $30,000 with $6 per unit cost. However, at 6,000 units, total costs went up by $3,000 and are now $33,000. But our cost per unit also changed. It went down and is now $5.50. Therefore, this would indicate this is a mixed cost. Total cost did go up, but not in direct proportion to the change in volume. So thus A is an example of variable. Our cost per unit stayed the same. B was fixed. Our fixed costs stayed the same. And then C was mixed, and it was a variety of the two, or a combination of the two. Let's take a look at an example. Here we've got information for a dry cleaner, and we've got three various levels. We've got 2,000, 3,500, and 5,000 garments that are cleaned. So we're going to be calculating various pieces of information. Let's start with the 3,500. If we cleaned 3,500 garments and each garment had a fixed cost of $2 per garment, we multiply those two for total fixed costs of $7,000. We add those two together for a total operating cost of $96.25. Then to calculate our variable cost per garment, we merely take our variable cost of $26.25. We divide that by 3,500 to arrive at 75 cents. We add those two together and it costs $2.75 to dry clean 3,500 garments. Well, we're also going to project out costs at 2,000 garments and 5,000. So let's go with a 2,000. Well, what do we know? We know that fixed costs are going to stay the same because we are assuming we're in the same relevant range. Well, so fixed costs of 7,000 divided by 2,000 garments gives us a fixed cost per garment of $3.50. Now we would expect it to go up because that same fixed cost of 7,000 is being spread over less garments or less units. All right, so let's go with variable costs. Well, we know that variable costs always stay the same. So we have 75 cents per garment. And when we add these two together, we have a price of $4.25 in cost, in average cost per garment. So now we just need to calculate our total variable costs. So 2,000 garments multiplied by 75 cents each is going to give us 1,500. We add the two together and we get total cost of $8,500. Now moving to the 5,000 range, we do the exact same thing. We know that fixed costs are going to be 7,000. Our variable cost per unit is going to be 75 cents. So let's calculate total variable costs at 75 cents multiplied by 5,000 garments. And that gives us a total of $37.50. When we add those two together, we get a total cost of $10,750. And we can now calculate our new fixed cost per garment at $7,000 divided by 5,000 garments, which gives us an amount of $1.40. Now we would expect the fixed cost per garment to go down because the same $7,000 is being averaged or split amongst more garments, or 5,000. So now when we add those two together, we have a total average cost per garment of $2.15. And that concludes this exercise of calculating various costs at different activity levels. Let's take a look at an example. Using the high-low method, we're going to calculate the variable cost per unit and fixed costs. So remember, we want the high and the low volume. So we're looking for the number of units. Looks like our high is going to be in April, and our low is going to be in May. So we're also going to need the costs that go along with those. These may not be the high or the low costs, but we don't care about that. We care about the activity level. So how do we calculate the variable cost per unit? Well, it's the change in cost over the change in volume. So we take our high cost of $5,800 and we subtract our low cost of $4,600, and that gives us a change of $1,200. Then we take the change in activity. So we have our high of 8,000 units, subtract our low of 6,000 units, and that gives us a change in units of 2,000. We then divide our change in cost over our change in volume, and that's going to give us 0.6. That's going to be our variable cost per unit. So therefore, this is 0.6. Now, how do we find the fixed costs? We just plug in the variable cost into one of the equations. So let's take our high. So if we produced 8,000 units and they were each 60 cents each, we are going to then multiply those two and we get an amount of 4,800. So this is total variable at a level of 8,000 units. So we merely take now the cost at the 8,000 level, which is 5,800, and we subtract off the total variable of 4,800 to arrive at fixed costs of 1,000. So thus our variable cost per unit was 60 cents and our fixed costs are $1,000. Given that information, we could plug in our variable cost and fixed cost to project total operating costs at any level within the relevant range. And in that case, the cost equation would be total costs would equal 60 cents per unit multiplied by the number of units plus fixed costs of $1,000. And that's it for now.